Okay, so now we are at this last line here, A times beta star equals R. And just as a reminder, this is we are on section 2.1 of this famous paper by Nelder and Wedderburn. The link to the paper and the complete playlist are in the description of this video. Okay, so before I move to my Blackboard and we show this, which is actually, it's not too difficult to show this, just some algebraic manipulation will get us there. But before I do that, I want to just talk about a few typos that we just need to clear up. You see here mu subscript k, and then up here there's not a subscript k. I noticed when I talked about this definition, or this CI, when I was talking about equation 9, I noticed that z should have had the subscript k, but I missed that mu should have also had the subscript k, and not same thing d mu dy. So it's correct here, and it was incorrect here. And so let's, I just want to talk about why I missed it, and what's going on. So remember, mu is the mean of z. So is the mean the same for every observation? That's basically what we need to think about. And if we go, well, z is a distribution who has a parameter theta, and theta is defined by some function of y, right? And depending on what observation k you have, y is gonna be different for each observation. So because y is different, theta is allowed to be different, which means that the mean is allowed to be different. So that's why, yes, we should have that subscript k both here, and it should have been up here in this one right here. Okay, so when I move to my Blackboard, you'll see that I've done that. It should have been zk, d mu k, and k is subscript everywhere else. Okay. Also, I like to be very clear about what I'm summing over. So in the paper, they don't necessarily always write what they're summing over, but I wrote it here just to clarify. All right. So now let's go ahead and start with A times beta star, and then we'll show that equals R. Okay. So let's go ahead and plug in by definition what beta star is. That's going to be our beta plus delta beta, to the change in beta, okay, which is A times beta plus A times delta beta, okay. By definition, A times delta beta, by equation 9, that is C. So that's C. Okay. So A times beta star, the ith element of it, right, because that's a vector, right, it's an m by 1 vector, so the ith element of that vector will be equal to the ith element of A times beta plus the ith element of C. Okay, so then we know what each of these are, so I just have to plug them in. So let's go ahead and do that. The sum from k equals 1 to n of wk xik yk, okay, plus right here I have C, so the sum from k equals 1 to n wk xik zk muk d muk dyk. All right, so then I notice that this and this are the same, and then I'm summing over k for both pieces of the sum, so I can pull that sum out. So k equals 1 to n, I don't need to write it twice, right? xik, and I have yk, so I'm basically pull out this piece here, so then I need my parentheses, plus zk mu k d mu k dyk. Okay, close those parentheses. All right, and then let's see, what do I have here? Okay, wk xik. This is this lowercase yk, right? They've written it that by definition that's what they've decided to use, right? Lowercase yk. You see it, they're the same, okay? And then we see that this is exactly what Ri is. Okay, so we've shown that A times beta star, the ith element of it is the ith element of R. So then when we use matrix or vectors, oops, I don't know why I put that star on the outside of the parentheses, it should be on the inside, beta star, oops, let me erase that, yeah. Alright, so when I have vectors, if the ith elements, then I can write that using vector notation. So this is m by 1 equals an m by 1, right?